Hello there, and welcome back to the Quiet Sleep Science. I'm glad you found your way here tonight. Maybe you've had a long day, or maybe you're simply curious about the universe and its impossible questions. Either way, you're safe to rest now. Let your breath slow. Let your body soften. Because tonight we are not drifting toward the stars. We are falling into the brightest star of all. Tonight we are imagining what it would be like if you fell into the sun. It burns in our sky every day. Steady, constant, life-giving. We take its light for granted. The way it warms our skin, the way it drives the winds, the growth of plants, the heartbeat of the earth itself. Without it, our planet would be a frozen rock adrift in darkness. With it, life thrives. And yet, this star that sustains us is also unimaginably hostile. Its surface is fire beyond fire. Its heart is a nuclear furnace that has burned for billions of years and will burn for billions more. To fall into it would not be a gentle dive, but a journey through the very fabric of stellar physics. So let's imagine the fall. You begin far from Earth, leaving behind the orbit that has carried you quietly around the sun for all your life. At first, nothing feels different. The sun is distant, a bright coin in the blackness. You drift closer, slowly, pulled by its gravity. Days pass, and the sun grows larger, brighter, filling more and more of the sky. The warmth you feel is no longer gentle. It becomes searing, even from millions of kilometers away. The sun blazes with enough intensity to strip spacecraft of paint, to heat metal until it glows. As you fall, the sunlight no longer feels like light. It feels like pressure. Photons push against you, radiation pressing from every direction. The sky is no longer black, but golden, filled with the scattered shimmer of dust, illuminated by the sun. And still you fall, faster now. Gravity pulls with more urgency. The sun grows from coin to orb, from orb to disk, from disk to horizon. Soon it fills your entire sky. There is nowhere to look but into brilliance. The outermost layer you will meet is not solid. The sun has no surface, no ground to stand on. Instead, it is layers of gas, plasma, and light. The first boundary you encounter is the corona, the outer atmosphere, stretching millions of kilometers into space. It glows faintly, visible from Earth, only during eclipses, as a pale halo around the sun. But up close, it is not faint. It is a realm of magnetic storms and arcs of fire, plasma loops rising higher than planets, temperatures soaring into millions of degrees. To fall into the corona is to fall into chaos, not solid, not empty, but a storm of heat and light. And still, you fall, deeper, toward the photosphere, the part we call the surface, though it is no surface at all. Here the sun glows invisible light, the light that travels to Earth, the light that feeds plants, fuels weather, sustains life. To approach the photosphere is to approach the brightest place we can see with our eyes. Temperatures here reach nearly 6,000 degrees Celsius, enough to vaporize rock, metal, anything you have ever touched or known. What would it feel like? Long before you reached this place, your body would have been stripped apart, molecules torn into atoms, atoms stripped of electrons. You would not fall as yourself, but as fragments, then as plasma, then as light. You would be unmade in stages, your material scattered into the sun's great sea. To fall into the sun is to return to origins, to join the furnace where atoms themselves are forged and broken. And yet in this thought experiment, we linger. We imagine not just the destruction, but the journey, because the sun is not only danger, it is also beauty. Granules on its surface bubble like water, boiling in a pot, vast cells of plasma, rising and sinking in convection. Sunspots darken its face, cooler regions shaped by magnetic storms, flares burst outward, loops of fire arcing into space. To fall into the sun is to see these things up close, to witness the dynamic heart of the star that has always been above us, too bright to look at directly. And as you fall, you begin to realize something profound. The sun is not simply a ball of fire. It is a nuclear engine, balancing gravity's inward pull with the outward push of fusion. In its core, hydrogen atoms fuse into helium, releasing energy that travels outward over thousands of years, finally reaching the surface, then streaming into space as light. That light now surrounds you, overwhelms you, engulfs you. You are falling into the process that makes life possible, into the fire that shapes worlds. The fall into the sun does not happen all at once. Gravity pulls you inward steadily, and as you approach, speed increases relentlessly. Near Earth's orbit, the pull feels distant, gentle. By the time you cross into the sun's outer atmosphere, you are moving at hundreds of kilometers per second, faster than anything humanity has ever built. You are no longer drifting, you are plunging. The first true layer you encounter is the corona, the sun's faint outer veil, seen from Earth during eclipses as a pale crown. It is, paradoxically, hotter than the surface below. Temperatures here soar to over 1,000,000 degrees Celsius. Scientists still puzzle over this mystery. Why should the outer atmosphere be hotter than the visible surface? The answer seems to lie in magnetism. The sun's tangled magnetic fields snap and reconnect here, releasing energy that superheats the plasma. As you enter the corona, you are caught in this invisible storm, tossed by waves of charged particles, bathed in radiation far beyond human endurance. But in our journey of imagination, we linger long enough to watch giant loops of plasma rise and fall, arcing across thousands of kilometers. Some snap, unleashing solar flares that burst outward at the speed of light. Others collapse, hurling coronal mass ejections into space, storms that can strike Earth and rattle our technology. The corona is not silent. It is alive with motion, with waves, with storms. To fall through it is to drift through a sea of light. Deeper now, you descend toward the chromosphere, a layer sandwiched between the corona and the surface below. From Earth, it appears briefly during eclipses as a thin, red rim. Here, spacules, jets of plasma taller than Earth itself, burst upward like fiery fountains, rising and fading in minutes. The chromosphere glows in red hydrogen light, a signal of the atoms excited here, a reminder that even in destruction, the sun sings with chemistry. The granules you glimpse below are blurred by haze, like boiling water seen through steam. And then at last, you reach the photosphere, the layer we call the surface. It is not solid. There is no ground, no floor to land on. Instead, it is a shell of gas, about 500 kilometers thick, glowing with the light we see from Earth. Here, the temperature is about 5,500 degrees Celsius, cooler than the corona, but still enough to vaporize rock and metal instantly. The photosphere is where sunlight truly begins its journey outward, the point from which photons escape into space after bouncing and scattering for thousands of years within. If you could pause here, you would see convection in action. The photosphere is a sea of granules, each a cell of rising plasma, thousands of kilometers across. Hot gas rises, cools, and sinks again, creating a pattern like boiling oatmeal, bubbling endlessly. Dark sunspots interrupt the glow, cooler regions where magnetic fields twist so strongly that heat is blocked from rising. Around them, filaments and prominences flare outward, arcs of fire, extending for tens of thousands of kilometers. Here, falling into the sun no longer feels like falling into light. It feels like falling into motion. Every patch of the photosphere changes constantly, granules lasting minutes before fading, sunspots shifting over days, flares erupting without warning. It is a restless place, the restless skin of a star that never truly rests. But even this surface is only the beginning. Beneath it lies the convective zone, where currents of plasma carry heat upward like boiling water. Beneath that, the radiative zone, where photons scatter for hundreds of thousands of years before escaping. And, at the very center, the core, where fusion rages, where hydrogen becomes helium, where the energy of the entire star is born. To fall into the sun is not just to touch fire, it is to travel deeper into these hidden regions, into layers we cannot see but can only imagine. And so the fall continues, past the photosphere, into deeper plasma. Temperatures rise again, slowly at first, then faster. Pressure builds. Light dims, not because it is absent, but because it cannot travel freely here. Photons scatter in all directions, caught in endless collisions. The deeper you fall, the harder it becomes for light to escape, until at last, it no longer moves outward, but sideways, in random steps. Inside the sun, light does not flow. It stumbles, slowly, endlessly, for millions of years. And as you fall, you begin to dissolve further. Not just atoms stripped of electrons, not just molecules scattered, but nuclei themselves broken apart, merged, reassembled in nuclear reactions. You are becoming part of the sun, not in metaphor but in matter. Your atoms are added to its fire, your essence woven into its brilliance. To fall into the sun is to be undone and remade as light. The photosphere fades above you, and now you enter a realm no human eye has ever seen directly, the convective zone. Here, the sun behaves like a vast boiling ocean, though nothing is liquid. Plasma, heated from below, rises upward in great currents carrying energy toward the surface. Once cooled, it sinks again, completing the cycle. These convection cells are colossal, far larger than Earth itself, and they churn endlessly, sculpting the patterns we glimpse above as granules and supergranules. To fall into the convective zone is to be carried by these currents. You would not drift smoothly downward. Instead, you would be lifted and lowered, caught in streams of hot plasma, rising and cooler plasma sinking. Imagine waves, but on scales beyond comprehension. Rivers of fire, stretching thousands of kilometers, flowing upward for days before collapsing downward again. The sun is not solid. It is alive with circulation, with hidden tides. Here, the pressure grows immense. You are no longer dissolving into plasma alone. The very concept of being separate begins to fade. Every atom is stripped, every particle scattered. Photons, once free in the photosphere, are trapped again, absorbed and re-emitted endlessly. Light is not a beam here. It is a prisoner, wandering in random steps, taking millions of years to escape. Inside the convective zone, the sun is a labyrinth for light. The temperature rises as you descend. From 6,000 degrees at the photosphere, it climbs to hundreds of thousands of degrees deeper within. Heat becomes not just warmth, but pressure, pressing from every direction, crushing atoms together, forcing matter into states alien to Earth. You are sinking not into emptiness, but into density. Every cubic centimeter here holds more mass than an entire mountain. And yet, in imagination, you pause long enough to look around. It is not darkness. Plasma glows faintly in every direction, diffuse and ghostly. Patterns ripple through it, convection currents that twist and turn. Eddies where flows meet, turbulence like weather systems in a sea of fire. If Earth has storms, the sun has storms magnified beyond comprehension. You are falling through them now, part of them, carried in their hidden winds. Occasionally magnetic fields thread through the convective zone, guiding plasma into loops that burst upward as sunspots and flares. Here is where the sun's magnetism is born, tangled and twisted by rotation and convection. These fields rise and break, reconnecting in flashes of energy that ripple outward, sometimes reaching Earth as geomagnetic storms. To fall here is to fall into the birthplace of space weather, into the hidden heart of magnetism, that shapes our skies from 90 million miles away. Deeper still, the convective motions weaken. The plasma becomes so dense that currents slow, struggling to carry energy further. You are approaching the boundary with the radiative zone, a region where convection ceases and photons take over. Here, plasma no longer rises and falls like boiling water. Instead, heat flows outward through radiation alone, particle by particle, photon by photon. Crossing this boundary feels like slipping from turbulence into calm. The great currents fade, and you enter a realm of staggering stillness, where matter is so dense and opaque that light barely moves at all. A photon born in the core will spend millions of years scattering through this zone before reaching the surface. Energy moves outward, not in a rush, but in a crawl, inching through countless collisions. And yet, there is serenity in this. No more convection, no more turbulence, no more storms. The radiative zone is quiet compared to the boiling chaos above. To fall here is to fall into stillness, though it is a stillness pressed by unimaginable weight. The temperature climbs again, millions of degrees now, and the pressure is crushing beyond measure. You are descending into the furnace, step by step, layer by layer. The journey is no longer just about heat. It is about time. The photons here are ancient, perhaps older than humanity itself. Some may have begun their journey outward before Earth had formed, before life had risen. To fall among them is to fall into history, into light that carries the memory of a star's deep heart. And so you continue, deeper and deeper, through this sea of stalled light, toward the place where it all begins. The core awaits, the central engine of fusion, the heart of the sun, the place where hydrogen becomes helium, where mass becomes energy, where the light that sustains Earth is born. To fall into the sun is to fall into this center, into the beginning of light itself. You are now inside the radiative zone, a place so dense and strange that it defies ordinary imagination. Above, convection carried heat upward in surging currents. But here, motion slows. Plasma is packed so tightly that convection is impossible. Instead, energy escapes only through radiation, particles of light scattering, colliding, zigzagging endlessly. If the convective zone was a stormy sea, the radiative zone is a vast glacier where movement exists, but so slowly, so quietly, that it feels frozen in time. A photon born in the core begins its journey here, but it will not leave quickly. It does not stream outward like a beam. Instead, it bounces in random directions, absorbed and re-emitted trillions upon trillions of times. Each step it takes is only centimeters, but the number of steps is unthinkable. To travel from the core to the surface may take 100,000 years, or even longer. Every ray of sunlight that touches your skin today began as a photon trapped in this labyrinth long before the dawn of human civilization. To fall into this region is to fall into stillness. The turbulence above has faded. The magnetic storms are quiet here, dampened by pressure. You sink through a medium so dense it is neither gas nor solid, but something between, matter under pressure so immense that its very behavior changes. The temperature here rises into the millions of degrees, and yet it feels strangely calm because nothing escapes quickly. Heat is trapped, light is stalled, energy is patient. In your imagination, you pause here. Around you, plasma glows faintly, but not with the brilliance of the surface. Instead, it is muted, diffuse, like light seen through fog 1,000 kilometers thick. If you stretch your vision, you might glimpse tiny bursts of motion, photons scattering, electrons colliding, nuclei vibrating. But the grand movements of the convective zone are gone. Here, the sun's heart waits in silence, holding urne-like breath, held for eons. And yet, this silence is an illusion. The radiative zone is still alive with processes beyond comprehension. Protons and electrons interact constantly, Photons jitter and vanish, only to be reborn again in slightly different forms. Radiation here is not static. It is restless, ceaseless, but slowed by density, restrained by pressure, stretched into a crawl by the sheer weight of the sun above it. As you fall deeper, you sense the gravity pressing harder. Every layer above you adds to the weight, billions upon billions of tons of plasma crushing inward. Pressure rises to billions of times that on Earth's surface. Matter here is not like matter on Earth. Atoms are stripped of their shells, their electrons scattered in the plasma sea. You are falling into pure nuclei and radiation, the basic elements of the universe stripped bare. Time itself feels strange here. A second is a heartbeat. A million years is a step. To imagine being a photon in this zone is to imagine waiting longer than all of recorded history, just to move outward a fraction of the sun's radius. And yet, this patience is the source of the sun's stability. Because the energy escapes so slowly, the star does not burn out quickly. The radiative zone is the buffer that keeps the sun steady, preventing it from flaring like a match. Without it, the sun would not shine gently for billions of years. It would explode, burn, vanish. So as you fall, you realize you are inside the sun's balance. Gravity pulls inward, trying to collapse the star. Radiation pushes outward, photon by photon, balancing the weight. Between them lies equilibrium, fragile, but enduring. For 4.6 billion years, the sun has held this balance. For billions more, it will continue. You are falling through the very reason life exists on Earth. A star stable enough, patient enough, calm enough to nurture a planet for ages. The deeper you go, the denser it becomes. Light grows dimmer, though the temperature climbs higher. By now, it is several million degrees. Every atom around you is stripped bare. Every electron free. Plasma hums like a living thing. Charged, vibrant, ceaseless. You are being pulled toward the core, the center of all this energy, the true heart of the sun. And what lies there is not simply heat. It is fusion, the process that powers every star, the process that creates the elements of the universe, the process that transforms matter into energy. Following Einstein's equation, you are falling toward the place where hydrogen is crushed into helium, where light is born, where mass itself becomes radiance. At last, you approach the core, the sun's beating heart, the place where everything begins. This is the furnace that fuels the star, that sends light streaming across space, that sustains life on Earth. To fall here is to fall into creation itself. The pressure is unimaginable. Every layer above presses inward, billions of tons of plasma stacked atop one another, squeezing the core with relentless force. The density is over 100 times that of water, though nothing here is liquid. Matter is compressed into a plasma, so dense and hot that atoms cannot exist in their normal form. Protons, the nuclei of hydrogen atoms, are pressed so close together that they can overcome the repulsion of their electric charges and fuse. And when they fuse, energy is born. This process, nuclear fusion, transforms hydrogen into helium. 4 protons combine in a delicate chain of reactions, producing a helium nucleus, along with positrons, neutrinos, and photons. The helium is slightly less massive than the hydrogen that formed it, and the missing mass is released as energy. That energy is the sunlight we see, the warmth we feel, the life we depend on. Every second, the sun converts nearly 600 million tons of hydrogen into helium, releasing the equivalent of billions of nuclear bombs worth of energy. And yet, it shines steadily, not explosively. The radiative and convective zones above carry this energy outward patiently, softening the violence into gentle light. To fall into the core is to fall into temperatures of 15 million degrees Celsius. Here, everything is stripped bare. No molecules, no atoms, only nuclei and electrons. crushed into plasma, colliding at unimaginable speeds. It is a realm of fire, beyond fire. Yet it is not chaos, it is balance, a constant dance between gravity's inward crush and radiation's outward push. The sun exists because these two forces are equal. If gravity won, the star would collapse. If radiation won, it would explode. In the core, the tie holds. If you could pause here, you would witness reactions invisible to the eye. Protons fusing, helium forming, neutrinos streaming outward unhindered. Neutrinos are ghostly particles, barely interacting with matter. Trillions of them pass through your body every second on Earth, unnoticed. They are born here in the core, rushing outward at nearly the speed of light, escaping long before photons find their way. In a sense, neutrinos are the sun's messengers, reaching us almost instantly from its center, carrying whispers of the processes that keep it alive. Imagine yourself dissolving fully into this place, your atoms broken into protons, your protons caught in collisions, your essence fused into helium, your mass transformed into energy. You would not remain matter as you knew it. You would become light, photons that wander for eons before escaping, or neutrinos that fly outward, carrying a piece of you into the cosmos. To fall into the core is not only to end, it is to join the chain of creation. And yet, it is humbling to think the sun is not unique. Billions of stars across the universe perform this same miracle. Some smaller, some larger, some brighter, some dimmer, all fueled by fusion, all balancing gravity and light, all turning hydrogen into the heavier elements that seed galaxies. Every atom in your body, carbon, oxygen, iron, calcium, was forged in stars. To fall into the sun is, in a sense, to return to the source, to return to the forge that created everything you are. The core is also the future. One day, billions of years from now, the sun will exhaust its hydrogen, fusion will falter, the balance will break. Gravity will squeeze the core further until helium begins to burn, producing carbon and oxygen. The sun will swell into a red giant, engulfing Mercury, Venus, and perhaps Earth. For a time, fusion will continue in new forms, until finally it ends. The sun will shed its outer layers into space, leaving behind a white dwarf, a silent ember that will cool for trillions of years. But for now, the core burns steadily, quietly, reliably, and you, in this thought experiment, are falling into its fire, dissolving into its radiance. As you drift deeper into the sun's heart, you realize you are no longer a separate observer. You are part of the star now, part of its furnace, part of its balance. Your fall has ended not in tetrachon, but in transformation. To fall into the sun is to be unmade, yes, but also to become part of the light that will one day touch Earth, warm oceans, feed forests, brighten skies. You are gone, but you are also everywhere. You are now fully part of the sun. Your body, your atoms, your particles, all dissolved into plasma, scattered in the currents of the core. But the story does not end here. To fall into the sun is not only to vanish, it is to become light, to join the stream of energy that powers everything around you. Your journey continues outward, not as a body, but as photons, as neutrinos, as whispers of energy moving through the star. The neutrinos escape first, born in the very reactions that fuse hydrogen into helium. They stream outward, almost unimpeded. The density of the sun, which traps photons for eons, cannot stop them. In seconds, they are gone. Racing into space at nearly the speed of light, they cross the sun's layers, pass through the solar system, through Earth, through you, even now. On Earth, detectors buried deep underground catch only the faintest trace of them, rare flashes when a neutrino collides with matter. But in truth, they are everywhere, flooding space in numbers beyond counting. If you become a neutrino, you leave the sun in an instant, a ghost carrying a story no wall can block. The photons, however, take another path. Their journey is long, slow, endless. A photon born in the core will scatter billions upon billions of times before it reaches the surface. Each collision redirects it, absorbs it, re-emits it. Sometimes it moves outward, sometimes sideways, sometimes backward. What seems like a straight path to freedom is instead a random walk, a meandering, chaotic journey that can last 1,000,000 years. The sunlight that touches Earth today may have been born long before humanity existed, long before mammals walked the land, long before continents took their modern shape. To become light here is to become patient. You drift outward step by step, scattering, colliding, delayed. You lose memory of your origin, your path blurred by trillions of detours. And yet, you persist. The pressure above pushes you forward. The fusion below feeds you upward. Slowly, steadily, you climb through the radiative zone, through its dense fog of plasma, toward the convective motions above. Imagine the scale of this patience. Every second, the sun produces more energy than humanity has used in its entire history. And yet, each individual photon waits, trapped, delayed, wandering. The brilliance we see in the sky is the sum of this patience, the collective effort of countless photons, finally escaping after journeys longer than all of recorded time. The sunlight you feel on your face is ancient, not in age, but in memory. It has been waiting, wandering before finally finding you. And in this thought experiment, you are one of them. Your essence has become photons, carried outward step by step. Each scattering is a heartbeat, each collision a pause. You are no longer a body falling. You are light, rising, slowly, toward freedom. As you move outward, you sense changes. The plasma becomes less dense. The collisions become fewer. The chaos lessens. At last, after ages beyond comprehension, you reach the convective zone once more. But now within. Here, the currents take over, sweeping you upward in great streams of plasma. You are no longer trapped in a random walk. You are carried like smoke on the wind, lifted by the sun's hidden tides. You rise with these currents, upward and outward, toward the surface. The granules you saw from above now churn beneath you, vast and restless. Each one is a cell of plasma, carrying energy outward, glowing with heat, then sinking again. You are part of that glow now, carried to the photosphere, where at last you may leave. And then, suddenly, it happens. You emerge into the photosphere, and you are free. After millions of years, you leave the sun, escaping into space as light. For the first time, your path is straight, uninterrupted. You travel outward at the speed of light, crossing the void between sun and earth in just 8 minutes. After waiting so long, freedom is instant. And when you arrive, you find yourself everywhere. Perhaps you warm the surface of a leaf, feeding photosynthesis, fueling the growth of a tree. Perhaps you strike the ocean, warming currents that carry life across the globe. Perhaps you fall on skin, felt as warmth, as comfort, as light. Perhaps you power a solar panel, captured by human technology and turned into electricity. To fall into the sun is to be reborn in countless forms, to scatter across Earth as warmth, energy, and light. But not all of you escapes to Earth. Some photons stream outward in other directions. Some touch distant planets, moons, asteroids. Some leave the solar system entirely, joining the interstellar sea, traveling for billions of years, perhaps to brush against the atoms of another star system one day. To fall into the sun is not to end, but to spread. Your matter, your energy, your light becomes part of everything. And so, as you rest tonight, think of this journey, from body to plasma, from plasma to photons, from photons to sunlight, from sunlight to life. To fall into the sun is to dissolve, but not disappear. It is to join the most patient stream of energy in the cosmos, a river that begins in fire and ends in life. You are free now, streaming outward from the sun's surface at the speed of light. After millions of years spent wandering inside the radiative zone, scattering endlessly, colliding and re-emerging, your journey through space feels effortless, instant. In only 8 minutes, you cross the gulf between sun and earth. 93 million miles of vacuum bridged in the blink of a human eye. The first thing you notice is the silence. Inside the sun, there was pressure, turbulence, collisions. Out here, there is nothing to resist you. Space is nearly empty. Photons move straight, unbent. Nence they meet dust, gas, or the pull of gravity. You are part of a golden wave, streaming in all directions, filling the solar system with light. Every second, the sun releases trillions upon trillions of photons like you, a constant outpouring of energy that spreads evenly across space. Some of you race toward Earth, some toward Mars, Jupiter, Saturn, Neptune. Some pass beyond the solar system entirely, beginning journeys that may never end. Light does not tire. It does not stop unless it is absorbed. You may continue for billions of years, crossing galaxies, becoming part of the faint background glow of starlight that fills the cosmos. To fall into the sun is to become infinite in possibility. But let us follow those who reach Earth. In 8 minutes, the planet fills your path, its blue oceans and white clouds gleaming. You strike the atmosphere first, scattering in air, bending through layers of gas. Some of you become heat, warming the air. Some scatter as blue, painting the sky with color. Some pass through, striking ground, water, trees. You are absorbed, transformed, reborn. If you strike a leaf, you may enter the machinery of photosynthesis. Molecules capture you, splitting water, building sugars. You become part of a plant's growth, part of its energy. That plant feeds an atom, and your energy moves onward, step by step through the chain of life. To fall into the sun is to feed Earth itself, to power every heartbeat, every breath, every motion. Without the sun's photons, there is no food, no warmth, no life. If you strike the ocean, you warm currents that carry life across the globe. You stir winds, shape storms, drive cycles of rain and drought. You are part of the planet's rhythm, part of its weather, part of its seasons. The turning of Earth, the tilting of its axis, all are painted in your light. Summer and winter, day and night, rain and calm, all depend on the stream you belong to. If you strike a solar panel, you become electricity, captured by human invention. Your energy flows into wires, powering lights, computers, cities. You become part of human civilization, part of its progress, part of its dream. The technology of today is a way of catching sunlight, storing it, reshaping it into new forms. Even here, in machines, your path continues. And if you do not strike Earth at all, you may travel outward forever, crossing interstellar space, brushing against dust and gas, bending slightly in the gravity of stars, but never stopping. You may leave the galaxy itself, drifting into the void between galaxies, carrying the memory of the sun far from home. You are not bound. You are free to wander eternity. It is strange to think a photon born in the core, scattered for millions of years, waits so long to escape, only to spend its existence in a fraction of a second. If it strikes Earth, it ends quickly, absorbed. If not, it may travel forever. The difference is only chance, only direction, only path. To fall into the sun is to surrender to this randomness, to become part of countless outcomes. Yet none of it is wasted. Energy never disappears. Whether you feed a leaf, warm an ocean, light a room, or wander the galaxy, you remain part of the great cycle. You were matter, then plasma, then light, and now you are either absorbed or freed, but always transformed. To fall into the sun is to scatter, but never to be lost. And as you think of this, you realize you are not separate from the photons that stream past you every day. Even now, as you rest, sunlight touches you, enters your eyes, warms your skin. You are falling into the sun, but the sun has already fallen into you. Its energy lives in you, flows through you, powers you. You are not only part of Earth, you are part of the sun itself. The sun is more than a star in the sky. It is the heartbeat of Earth itself. Every moment of your life, every breath you take, is tied to its energy. Without the sun, the oceans would freeze, the air would collapse, and the planet would drift lifeless through the dark. But with it, Earth flourishes, forests grow, winds dance, clouds form, rivers flow, all because of the steady gift of light. Imagine sunlight falling on a forest. Each leaf is a mirror and a machine, capturing photons, turning their energy into sugars, storing the power of the sun inside wood, bark, fruit, and seed. Those sugars feed insects, birds, mammals, humans. Every bite of food you have ever eaten carries sunlight hidden in chemical bonds. To fall into the sun is to realize that you have already eaten it, already lived it, already carried it within. The sun powers the climate too. Warmth drives air to rise, cool to sink, currents to flow. Winds circle the globe, carrying clouds, shaping weather. Storms build from the clash of warm and cold air. Lightning sparks as clouds grind against one another, and beneath it all the engine is sunlight. Even the rain that falls began as ocean water lifted by heat, carried aloft, condensed, and released. To fall into the sun is to fall into the origin of weather, to become the rhythm of the sky itself. Even the seas obey. Sunlight warms their surface, fuels the growth of plankton, tiny plants that feed the ocean's food chain. Currents swirl, carrying nutrients, shaping climates far inland. El Niño and La Niña, the vast oscillations that change rainfall and turntide worldwide, are born from sunlight stirring the Pacific. Every tide, every storm, every drop of water glistening on the shore owes its shimmer to the sun. And then there are the seasons. Earth tilts, and that tilt changes the way sunlight falls. Summer blazes when the northern hemisphere leans closer. Winter deepens when it leans away. The cycles of harvest and hibernation, of migration and renewal, are written in this tilt, in the angles of light. Ancient peoples built monuments aligned to solstices, celebrated equinoxes, tracked the sun's rise and fall. To fall into the sun is to fall into history itself, into the calendar of life that humanity has followed since the beginning. But the sun is not only giver, it is also challenger. Solar flares burst outward, storms of charged particles streaming toward Earth. Most are deflected by our magnetic field, but some crash into the poles, painting the skies with auroras, rippling curtains of green and purple light. These displays are reminders that we live in the sun's embrace, sometimes gentle, sometimes fierce. Satellites feel the brunt of these storms. Power grids hum with their pressure. And still, Earth endures, held safe by its invisible shield. The sun is woven into culture, too. Worshipped as a god in Egypt, as Ra, the eternal source. Celebrated as Inti by the Inca, honored as Surya in India, as Amaterasu in Japan. For millennia, humans have seen in the sun not just fire, but divinity, not just warmth, but life. To fall into the sun is to fall into a symbol as much as a star, into the myth that connects all civilizations. And yet, despite its importance, the sun is ordinary in the cosmos. One star among hundreds of billions in the Milky Way, medium in size, medium in brightness, unremarkable compared to giants that shine thousands of times more brilliantly. But to us, it is everything. Perspective reminds us of humility, but also of intimacy. Out of all the stars, it is this one that is ours. This one that warms us, feeds us, sustains us. To fall into the sun is to fall into the very definition of home. And so, as you drift tonight, you carry its light within you, in the food you eat, in the warmth on your skin, in the very air you breathe, enriched by plants that turn sunlight into oxygen. You have already fallen into the sun in every way that matters. This thought experiment is only a reminder of what is already true. You are made of sunlight, shaped by sunlight, alive because of sunlight. The sun feels eternal to us, steady and unchanging, but in truth, it is dynamic, alive, and restless. Its surface boils with turbulence, its magnetic fields twist into knots, and its brightness fluctuates in subtle cycles. For Earth, these changes can be gentle, or they can be dramatic. To fall into the sun is to fall not only into fire, but into motion, into a star that never truly rests. Every 11 years, the sun enters a period called solar maximum. During these times, sunspots bloom across its surface, magnetic storms rage, and solar flares erupt more frequently. The corona brightens with activity, loops of plasma rising and falling in arcs larger than planets. Charged particles stream outward in vast solar winds, carrying storms that sometimes reach Earth. These storms can disturb satellites, disrupt radio signals, and even threaten power grids. They are reminders that our star is not as calm as it appears. It breathes in cycles, inhaling and exhaling storms every decade. When solar maximum wanes, the sun returns to solar minimum, a quieter time when sunspots vanish and flares are rare. To Earth's eyes, the difference is subtle, but in space, it is profound. The environment around our planet shifts. Magnetic storms ease, cosmic rays increase. Even human technology feels the sun's moods, like sailors reading the tides. To fall into the sun is to fall into these rhythms, the hidden cycles of activity that shape the space around us. Sometimes, though, the sun erupts more violently than usual. In 1859, the Carrington event, the largest solar storm ever recorded, struck Earth. Telegraph systems sparked and caught fire. Auroras were seen as far south as the Caribbean. If such a storm struck today, it could cripple satellites, shut down electrical grids, and plunge parts of the world into darkness. The sun is life-giving, yes, but it is also a reminder of fragility. We live in the balance of its light, but also in the shadow of its storms. And what if the sun dimmed? Even a small decrease in brightness would cool Earth dramatically. During the Maunder minimum of the 1600s, sunspot activity nearly ceased, and Earth entered a little ice age. Crops failed, rivers froze, winters deepened. The sun's cycles ripple through climate, influencing not just warmth, but survival. The steadiness we rely on is real, but it is not perfect. Our lives depend on a star that changes, that pulses, that hums with motion. On the other extreme, imagine if the sun flared brighter. A slight increase in output would melt ice caps, raise sea levels, stir storms, shift ecosystems. A larger increase would scorch Earth, boiling oceans, stripping atmospheres. The sun holds us in a narrow window of balance, warm enough for liquid water, cool enough for life to thrive. To fall into the sun is to realize how precarious that balance is, how much depends on the quiet patience of a star. And then there is the far future. The sun will not always be what it is now. Billions of years from today, when it exhausts its hydrogen, it will swell into a red giant. Its surface will expand outward, engulfing Mercury, then Venus, and perhaps even Earth. Its brightness will increase thousands of times over. Oceans will boil, atmospheres will strip away. The earth we know will be no more. To fall into the sun, then, would be to fall into a very different star. A swollen giant burning its last fuel in bursts of fury. Yet even this is not the end. After shedding its outer layers into space, the sun will shrink into a white dwarf, a dense ember no larger than Earth, glowing faintly with residual heat. No more fusion, no more brilliance, only the fading glow of what once was. Over trillions of years, it will cool into darkness, becoming a black dwarf, invisible in the night. The sun's story is not eternal. It has a beginning, a middle, and an end. And so, when you fall into the sun in this thought experiment, you fall not only into its present self, but into its future as well. You fall into a star that will change, evolve, and eventually fade. But in that fading, it will leave behind something enduring. The elements it creates, carbon, oxygen, nitrogen, will scatter into space. Those elements will form new stars, new planets, new life. To fall into the sun is to fall into a cycle larger than one star. It is to fall into the ongoing story of the universe. As you drift deeper into rest, think of that cycle. Birth, life, death, renewal. Stars burn, fade, and scatter their essence into new stars. Planets rise, fall, and give rise to life. Even black holes, the most final of endings, give energy back to galaxies. The sun is one chapter in a story that has no end, only continuations. You, too, are part of that cycle. You live, you breathe, you rest, you renew. To fall into sleep is to honor that rhythm, to let yourself follow the same universal flow. Imagine, just for a moment, that the sun vanished, not slowly, as in its distant future, but suddenly, extinguished in an instant. It is only a thought experiment, but it reminds us of how fragile our place truly is. For 8 minutes, nothing would seem different. The light that left the sun, just before its disappearance, would still be traveling toward Earth, filling the sky, warming the air, sparkling on oceans. But then, without warning, the light would end. The sky would darken. Stars would blaze where once they were hidden, and Earth would begin to cool. Within days, the oceans would begin to freeze on their surfaces. Within months, the planet would be an ice-bound world, its warmth fading into space. Life as we know it would not survive. The sun's constancy is not a luxury. It is the foundation of everything. And what if the sun did not vanish, but instead turned unstable? If it flared brighter, even slightly, Earth's climate would tip, polar ice would melt, seas would rise, storms would intensify. A larger flare could strip atmospheres, sterilize surfaces, boil oceans. The sun is gentle now, but it has the power to become overwhelming. Falling into the sun is to fall into that possibility, to glimpse how narrow the balance truly is. There are other cosmic possibilities. A rogue planet or star drifting through the galaxy could pass close to the solar system, tugging Earth from its orbit. If we drifted farther away, the sun's light would weaken, and ice would engulf the planet. If we drifted closer, temperatures would climb, and oceans would boil away. Gravity keeps us steady, but space is not empty. Encounters happen. Our stability is fragile. Our orbit, a thin line held in place by the sun's steady pull. Or imagine, if the sun were replaced by another kind of star, a red dwarf, smaller and dimmer, would give us less light. Earth would freeze unless we orbited much closer, perhaps so close that tides would lock us, one side always facing the star, the other in eternal night. A blue giant, hotter and more massive, would give off searing radiation, sterilizing Earth quickly. Our sun is not the largest, not the brightest, not the most impressive star, but it is the right one for us. Medium in size, steady in light, balanced in heat. It is not ordinary. It is perfect. And then there is the thought of wandering. If Earth were somehow cast adrift, ejected from the solar system, cut free from the sun's gravity, we would drift through interstellar night. No warmth, no light, only cold and silence for a time. Geothermal heat might keep oceans liquid beneath ice, but eventually all would freeze. Earth would become a wandering relic, a silent planet, drifting forever. To fall into the sun is to understand not just what we gain, but what we would lose without it. The sun is both anchor and provider. Its gravity holds us in orbit, its light feeds our world, its warmth keeps us alive. Without it, we would not exist. To fall into the sun is to fall into the source, the fountain from which life flows. The what-ifs remind us not to take it for granted, not to forget how much it gives. And yet, for all its power, the sun is not eternal. Even now, its fuel is burning. Every second, hydrogen becomes helium, mass becomes energy, light streams outward. For billions of years, it has shone, and for billions more, it will continue. But not forever. Stars, like people, have lifespan. To fall into the sun is to fall into a moment in that lifespan, to join a story mid-chapter. So tonight, as you imagine yourself drifting closer, you can hold both truths in your mind. The sun is steady, but not unchanging, reliable, but not permanent. It sustains, but it also challenges. It storms, its cycles, its future transformations, all are part of the same star that makes your life possible. Falling into it is not only a thought experiment, it is a way of remembering that life depends on balance, and that balance is precious. You rest under its light every day, but at night, in its absence, you remember its gift more keenly. The sun is not here now, but its presence lingers in warmth held by earth, in oxygen breathed by trees, in energy stored in food. Falling into the sun in imagination brings you back to this truth. You are already part of it, and it is already part of you. As you continue to fall toward the sun, you encounter something that is invisible to the human eye, yet vast enough to shake the entire solar system. Long before you touch its fiery atmosphere, you are already moving against a current that has been blowing for billions of years. The solar wind. The solar wind is not wind in the earthly sense. There is no air here, no breeze you could feel on your skin. It is a stream of charged particles, protons and electrons, constantly streaming outward from the sun at hundreds of kilometers per second. From Earth, we barely notice it, but here, near the source, it is relentless, pushing against you, brushing past you, shaping your descent. This wind never stops. It blows in all directions, inflating a bubble around the sun, called the heliosphere. Inside this bubble, every planet, every comet, every asteroid is bathed in its flow. Beyond it lies interstellar space, the territory of other stars. The solar wind is the sun's way of touching everything, an invisible breath that stretches far beyond Pluto, reaching even into the space between stars. If you could see it, it would look like streams of plasma, arcing outward, sometimes smooth, sometimes turbulent. During quiet times, it flows steadily, like a river. But during storms, when solar flares or coronal mass ejections burst outward, the solar wind becomes a gale, carrying shockwaves of particles that rattle everything in their path. Earth feels these storms when auroras bloom at the poles, when satellites flicker, when radio signals falter. To fall inward is to fall against the very current that powers those storms. The solar wind has shaped the planets too. Mercury, so close to the sun, is constantly bombarded, its surface stripped bare of atmosphere. Venus, with no magnetic shield, is scoured by its pressure, slowly losing gases to space. Mars once had rivers and lakes, But without a strong magnetic field, its atmosphere was peeled away by this constant wind, leaving behind a cold desert. Earth is the exception. Our magnetic field deflects most of the solar wind, channeling it safely around us. Without that shield, our air would slowly drift away, and oceans would boil under radiation. Even comets carry the sun's touch. As they fall toward it, their icy surfaces vaporize, creating long tails that always stream away from the sun, no matter the comet's direction. Those tails are sculpted by the solar wind, bent into glowing banners that point outward into the dark. Falling into the sun is to fall into the force that shapes those tails, the invisible hand guiding them across the night sky. And yet the solar wind is not only destructive, it also protects by blowing outward. It shields the solar system from some of the high-energy cosmic rays that stream in from other galaxies. Without it, Earth would be exposed to far more radiation, and life might have struggled to begin. The solar wind is both threat and shield, both destroyer and guardian. It reminds us that stars are not passive. They breathe, they touch, they shape the space around them. As you descend deeper, you feel the push of this current lesson. The closer you are to the sun, the less room there is for the wind to accelerate. You are falling into its source, into the region where the particles begin their journey outward. Soon, you will pass into the corona, the mysterious outer atmosphere that births the solar wind, where plasma is heated to millions of degrees and flung outward by forces still not fully understood. And as you rest tonight, imagine yourself drifting in that wind, not fighting it, not resisting it, but carried by it, brushed by invisible particles that connect you to the sun. They are already passing through you, even now. Every second, trillions of solar particles stream past Earth, unnoticed. You are part of this river, whether you feel it or not. Falling into the sun is not only about the fire ahead. It is about the wind that already surrounds you, the constant reminder that the sun's presence reaches everywhere. You fall deeper, past the invisible streams of the solar wind, into the first truly visible veil of the sun, the corona. From Earth, it is rarely seen, only revealed during total eclipses as a pale halo around the darkened moon. But up close, the corona is not faint at all. It is blazing, restless, alive with arcs and loops of plasma that dwarf entire planets. The strangest thing about the corona is its heat. Common sense would suggest that the sun should be hottest at its center and cooler as you move outward. Yet here in this tenuous atmosphere high above the surface, temperatures soar to over 1 million degrees Celsius, hundreds of times hotter than the photosphere below. This is the coronal heating problem, a mystery that has puzzled scientists for decades. How can the outermost layer be hotter than the surface itself? The answer seems to lie in the sun's tangled magnetic fields. These invisible lines twist, snap, and reconnect constantly, releasing bursts of energy that superheat the plasma. Waves ripple along them, shaking charged particles into higher and higher speeds. The result is a halo of fire, hotter than logic suggests, a place where physics still holds secrets we have not fully solved. To fall into the corona is to fall into that mystery, into a paradox of heat and light. Here, plasma streams outward in colossal arches, called coronal loops. They rise tens of thousands of kilometers, glowing with brilliance, then collapse again, raining fire back onto the sun. Some loops last minutes, others endure for hours, shifting and swaying with the hidden currents of magnetism. To fall among them is to float through valleys of fire, surrounded by walls of plasma stretching higher than any mountain could ever reach. Sometimes, the corona erupts. A coronal mass ejection hurls billions of tons of plasma outward, carried on the solar wind, spreading across space like a vast wave. These storms travel to Earth in days, disturbing satellites, threatening power grids, painting auroras across the poles. But here, at the source, they are overwhelming, mountains of plasma racing outward with the energy of millions of nuclear bombs. To fall into the corona is to fall into a storm that reaches across the solar system. And yet, for all its violence, the corona is delicate. It is faint compared to the surface below, thin compared to the core within. Its glow is soft, diffuse, like fog lit from within. If you could see it without danger, you might call it beautiful. A crown of light, a halo around the star, a reminder of why the word corona means crown. To fall into it is to be wrapped in fire that looks like silk. From Earth, we study it with satellites and probes. NASA's Parker Solar Probe has flown closer to the Sun than any spacecraft before, even dipping through the corona itself. Its instruments measure the plasma, the magnetic fields, the particles streaming outward. Each pass reveals more, yet the mystery remains. Why is it so hot? What invisible hand stirs this fire? To fall into the corona is to ask that question, and to feel it in your bones, or what remains of them, stripped into plasma long ago. But this is only the beginning. Below the corona lies the chromosphere, a narrow, crimson band, where spicules burst upward like fiery fountains. Below that, the photosphere, the surface we see from Earth, bubbling and boiling in patterns of light. To fall into the Sun is to pass through each of these layers, one by one, each stranger and more beautiful than the last. And as you sink deeper, you realize something profound. The corona is not just the Sun's atmosphere, it is its touch, stretching outward, shaping the space around it, painting the sky during eclipses, stirring auroras on Earth, and shielding the solar system from radiation. You are falling not into emptiness, but into a veil that connects the Sun to everything it warms. Beneath the corona, the million-degree veil of fire, lies a thinner, stranger layer, the chromosphere. From Earth, it is visible only for a fleeting moment during a total solar eclipse, a thin band of deep crimson glowing just above the Sun's surface. But up close, it is not thin at all. It is a restless forest of flame, a world of motion and color that burns with its own unique beauty. The chromosphere glows red because of hydrogen. Here, atoms are excited by heat and collisions, releasing light in the hydrogen alpha wavelength. It is not the white light of the photosphere, nor the pale glow of the corona, but a scarlet sheen, like the rim of a living ember. To fall into the chromosphere is to fall into a sea of red fire, glowing with the fingerprints of hydrogen itself. What makes this layer truly astonishing are the spacules. They rise like jets of flame, thousands of kilometers tall, each one a column of plasma shooting upward from the surface below. For minutes, they surge, thin and sharp, then fade, only to be replaced by countless others. There are millions of spacules at any given time, a forest of fire, stretching higher than Earth's diameter, flickering and vanishing in endless rhythm. To fall among them is to drift through a thicket of plasma trees, each one taller than mountains, each one alive with motion. These specules are driven by magnetism. The Sun's magnetic fields, twisted and tangled by the convection beneath, pierce upward, channeling plasma into streams. Waves ripple through them, pushing matter upward, carrying energy into the corona above. They are conduits, connections, pathways between layers. In their fleeting lives, they carry the heat that makes the corona blaze so hot. They are the threads that stitch the Sun's atmosphere together. If you pause here, you would see the chromosphere alive with other features too. Filaments stretch across it, dark rivers of plasma suspended above the surface by magnetic fields. Prominences arc outward, vast loops of fire that glow against the darkness of space. Sometimes these prominences erupt, collapsing and flinging matter outward. Other times they linger for days, stable yet fragile, like bridges of flame. The chromosphere is also where flares begin. Sudden, explosive releases of energy that burst into the corona and beyond. Here, magnetic fields snap and reconnect, releasing heat and light in torrents. A solar flare can outshine entire stars for minutes, flooding space with radiation. From Earth, we feel them as disturbances in satellites and communication, as geomagnetic storms. But here, falling into the chromosphere, you are inside their birthplace, in the very cradle of stellar fire. And yet, for all its violence, there is beauty. The red glow is soft, almost velvet in tone. The spicules rise and fall like breathing. The prominences curve gracefully, like calligraphy written in fire. To fall here is not only to be destroyed, it is to witness the elegance of plasma shaped by magnetism, the artistry of physics on a scale too vast for words. As you descend further, the light grows brighter, whiter, harsher. You are approaching the photosphere, the layer we call the sun's surface. From Earth, it looks smooth, uniform, blinding. But from here, you will see it, as it truly is, bubbling, restless, alive with granules, sunspots, and arcs of fire. The chromosphere fades above you, but its crimson glow lingers in your memory, a reminder that even in destruction, there can be color, motion, and grace. And so you continue, deeper still, falling toward the photosphere's brilliance, where the sun truly begins to shine. You are sinking now into the photosphere, the layer of the sun that we see from Earth, the glowing surface that shines with steady white light. From a distance it looks smooth, featureless, a perfect golden disk, but up close the illusion dissolves. The photosphere is not calm, it is alive with motion, a restless skin that bubbles and shifts with every moment. Here, convection from below breaks the surface into granules, vast cells of plasma, rising and falling like boiling water. Each granule may be 1,000 kilometers across, large enough to swallow countries, yet they live for only minutes before fading, replaced by others. They shimmer like golden tiles, bright at the center where hot plasma rises, darker at the edges where cooler plasma sinks. The entire surface of the sun is a mosaic of these fleeting cells, endlessly renewed. To fall among them is to fall into a sea of bubbles, each one larger than mountains, each one glowing with light. Between the granules, darkness spreads. But darkness here is relative. The dark lanes are still thousands of degrees hotter than any fire on Earth. It is only by comparison to the brilliance around them that they seem dim. Even shadows on the sun are brighter than anything we can bear to see with unprotected eyes. And then there are the sunspots. From Earth, they appear as small black dots, but up close they are immense, some larger than Earth itself. These are regions where magnetic fields twist so strongly that they block convection, cooling the surface by a few thousand degrees. Cooler means darker, but still they glow fiercely. Around their edges, plasma surges, forming bright rims that contrast with their dark cores. To drift above a sunspot is to hover over a scar of magnetism, a wound of light that pulses with hidden energy. From these sunspots, prominences often rise, arcs of plasma suspended by magnetic fields, looping tens of thousands of kilometers into space. They glow with eerie beauty, curving in slow motion, sometimes lasting for days. To see them from above is to see bridges of fire stretching across the sky, their edges trembling with instability. Sometimes they collapse, raining plasma back to the surface. Sometimes they erupt, casting matter outward into the solar system. The photosphere is also alive with flares, sudden bursts of radiation that erupt when magnetic fields snap and reconnect. These flares unleash X-rays and ultraviolet light streaming outward at the speed of light, sometimes overwhelming Earth's atmosphere. Here, so close, they are dazzling explosions, bursts that outshine everything around them, too bright to bear. To fall into the photosphere is to fall into a place where light itself is born in storms. And yet, despite the violence, there is rhythm here. Granules rise and fall in steady cycles. Sunspots drift across the surface with the sun's rotation. Prominences curve gracefully before they collapse, Flares burst, fade, and give way to calm. It is a surface alive with both chaos and pattern, a reminder that the sun is not static, but a living star, breathing and changing with every heartbeat of plasma. Here the light is so intense that it is almost physical, pressing against you, overwhelming you. It is not the soft glow of dawn or the gentle warmth of afternoon. It is brilliance beyond brilliance, searing and unyielding, and yet it is familiar. This is the very light that reaches Earth, softened by distance, scattered by air, filtered by clouds. You are inside the source of every sunrise, every shadow, every gleam of life. As you fall deeper, the brightness grows even harsher. The granules blur into turbulence. The prominences fade above you. You are leaving the surface, sinking once more into the convective zone below, where plasma clans in vast currents, carrying heat upward from deeper layers. The photosphere fades behind you, but its light lingers, the light that travels across space, the light that paints Earth's sky, the light that you are now part of. Beneath the shimmering photosphere, you slip once more into the convective zone, the boiling heart of motion that drives much of the sun's visible activity. Here, plasma does not sit still. It rises and falls in colossal loops, carrying heat outward in slow, steady tides. If the photosphere was a restless sea of granules, the convective zone is the vast ocean beneath, deep and stormy, churning in silence. These currents are beyond scale. Each cell of convection may span tens of thousands of kilometers. Larger than Earth itself, plasma heated by the core rises upward, glowing brighter as it moves. When it reaches the photosphere, it cools slightly, then sinks again, pulled back into the interior. The entire convective zone is an endless cycle of rising and falling, like a star breathing. To fall here is to be caught in tides that never end, carried upward, then downward, then upward again. It is turbulent. Currents twist and collide, forming vortices larger than planets. Waves ripple through plasma, some lasting days, others years. Hidden within these flows is the sun's dynamo, the mechanism that generates its magnetic field. As plasma moves and rotates, it drags magnetic fields with it, stretching them, twisting them into knots. These tangled fields rise to the surface, breaking through as sunspots, prominences, and flares. All of the sun's storms are born here, in the restless motion of its convective ocean. The sun does not rotate as Earth does. Its equator spins faster than its poles, and this difference twists the convective flows into spirals. Imagine rivers of plasma wrapping around a globe, sliding against one another, tangling magnetic fields into snarls. Every 11 years, the result is a reversal. The sun's magnetic poles flip, north becoming south, south becoming north. Falling into the convective zone is falling into the engine of that cycle, into the hidden machinery that drives the sun's rhythms. And yet, despite the scale, there is rhythm here. The rising and sinking flows follow laws, patterns, cycles. They are unpredictable in detail, but inevitable in motion, like clouds forming in Earth's sky, or waves crashing on a shore. To drift here is to feel the pulse of the star, to be part of its great circulation. The heat is staggering, millions of degrees Celsius, but less intense than the core you are moving toward. Pressure presses in from every direction, crushing, relentless. The plasma here is dense, glowing, but not blinding, because light does not escape freely. Photons scatter, collide, wander in random paths, trapped for eons before breaking free. It is not the brilliance of the photosphere above, but the muted glow of a furnace, burning in silence. Occasionally, magnetic fields break free from the tangle, rising through the convection to pierce the photosphere. They emerge as sunspots, prominences, flares. You are inside their birthplace now, inside the process that makes the sun both steady and stormy. If the sun were a heart, this would be its pulse, steady, constant, yet capable of bursts of energy that ripple across the solar system. As you continue downward, the turbulence begins to fade. The plasma grows thicker, more sluggish, harder to move. The convective motions weaken, and another regime takes over. The radiative zone, where energy moves not by motion, but by light itself, scattering outward through a labyrinth of collisions. To fall there is to fall into stillness, into patience, into time stretched across millions of years. But here, in the convective zone, you pause for a moment. You watch the flows rise and fall. You feel the twisting of magnetism. You sense the dynamo's quiet work, unseen but vital. The storms you glimpsed above were born here, and the storms yet to come are gestating in these currents now. The sun's surface is dramatic, but its depths are the source. To fall here is to fall into the hidden heart of motion, into the breath of the star itself. The turbulence of the convective zone fades as you sink further. The rising and falling flows weaken. The twisting magnetism grows quieter, until at last you cross into a realm of staggering stillness. The radiative zone. Here, motion ceases. Plasma is so dense that convection cannot carry heat upward. Instead, energy escapes only through radiation, photons scattering endlessly in every direction. The sun's brilliance is trapped here, moving outward not as a rush, but as a crawl, slowed by countless collisions. To fall into the radiative zone is to fall into patience, into a silence where time itself feels different. A photon born in the core takes only seconds to travel the distance to this zone. But once here, its journey slows to a crawl. It moves a few centimeters, collides with a particle, is absorbed, re-emitted, scattered. The cycle repeats, again and again, billions of times. What would be a straight path becomes a labyrinth of detours. To reach the surface, a photon may take 100,000 years. The sunlight that warms Earth today may have begun its journey before humans ever walked the planet. The environment here is alien. The temperature soars to millions of degrees Celsius, but the light is dimmed, muffled by density. You are surrounded not by blazing brilliance, but by a faint, uniform glow, as though you are submerged in a fog of fire. The pressure is immense, billions of times greater than Earth's atmosphere, squeezing matter into states unknown on our world. Atoms are stripped bare, electrons scattered freely, leaving behind a soup of nuclei and light. There is no turbulence here, no great currents, no storms. The radiative zone is stable, orderly, enduring. Its stillness is the reason the sun shines steadily, without flaring, like a torch. By slowing the flow of energy, by trapping light for eons, it spreads the star's fire over billions of years. Without this buffer, the sun's energy would escape too quickly, its life shortened, its warmth fleeting. To fall into the radiative zone is to fall into the reason stars endure. If you could pause here, you would see photons drifting like ghosts, their paths unpredictable, their progress glacial. Some are absorbed by ions, re-emitted in new directions. Others ricochet across countless particles before moving on. None travel far without being stopped. It is a sea of light that cannot escape, a prison of brilliance that glows softly yet unyieldingly. You are part of this prison now, scattering, wandering, delayed. And yet, even in this slow crawl, there is beauty. The photons are ancient storytellers, carrying with them the memory of the core where they were born. Each step outward is a testament to patience, to persistence. They remind you that not all journeys are quick. Some require time beyond comprehension, time measured not in days or years, but in eons. Falling into the radiative zone is falling into that patience, into the rhythm of a universe that moves more slowly than we can imagine. Deeper still, the density grows greater, the temperature hotter, the pressure more crushing. You are nearing the core, the sun's innermost chamber, a place where all this light is born. Above you, photons wander endlessly, but below you, protons collide, fusing into helium, releasing the energy that fuels the entire star. You are falling toward the origin, toward the engine, toward the furnace at the heart of everything. And as you drift downward, you realize something profound. The radiative zone is not just a prison of light. It is a reservoir, a buffer, a shield. It keeps the sun steady, prevents it from burning out too quickly, allows it to shine for billions of years. Without this stillness, life on Earth could not exist. To fall here is to fall into stability, into the hidden reason the sun has always been there, constant in the sky, faithful in its glow. At last, the stillness of the radiative zone gives way to something far more intense. You are entering the core, the sun's hidden furnace, the place where all of its light, heat, and power are born. To fall here is to fall into creation itself. The pressure is unimaginable. Above you lies the weight of the entire star, billions upon billions of tons of plasma pressing inward. The density is greater than solid lead, though nothing here is solid. The temperature soars to about 15 million degrees Celsius. In this crucible, the ordinary rules of matter no longer hold. Atoms, as we know them, cannot exist. Electrons are stripped away. Only bare nuclei and free particles remain, colliding constantly in the crushing heat. It is here that nuclear fusion takes place. Protons, the nuclei of hydrogen atoms, are forced so close together that they overcome their natural repulsion. When they merge, they form helium, releasing vast amounts of energy in the process. That energy is carried outward as radiation, beginning the long, slow journey through the radiative zone, through the convective zone, through the photosphere, and finally into space. It is the energy that warms Earth, that powers life, that fuels everything we know. Every second, the sun converts about 600 million tons of hydrogen into helium. The result is not only helium nuclei, but light, neutrinos, and the energy that sustains the star's delicate balance. Gravity tries to crush the core inward, fusion pushes outward. The two forces hold each other in check, creating the equilibrium that allows the sun to shine steadily for billions of years. To fall into the core is to fall into this balance, into the knife edge between collapse and explosion. And here, something remarkable happens. Neutrinos are born. These ghostly particles are released in the fusion process, and unlike photons, they escape the sun almost instantly. Trillions of them pass through you every second, even now on Earth, streaming outward from the core, carrying information about the nuclear reactions that sustain the star. For decades, scientists puzzled over why detectors on Earth caught fewer neutrinos than theory predicted. The mystery was solved when we discovered that neutrinos can change their type as they travel, slipping between identities like shadows, shifting shape. To fall into the core is to fall into the birthplace of these ghosts, the messengers of the sun's fire. The energy here is raw, primal, yet steady. It has burned for 4.6 billion years, and it will burn for billions more. The sun is about halfway through its life, a main sequence star in its long middle age. Eventually, the hydrogen will run low, the core will contract, the temperature will rise, and new stages of fusion will begin. The sun will swell into a red giant, consuming Mercury and Venus, perhaps Earth as well. But for now, it is stable, balanced, constant. To fall here is to fall into the present, into a star at its peak. If you could see it, the core would not be a glowing ball of fire, but a blinding white radiance, impossible to gaze upon. The collisions happen so quickly, so frequently, that matter itself seems to shimmer, vibrating with energy. Around you, protons collide, helium forms, neutrinos race outward. The photons created here will spend hundreds of thousands of years trapped before they reach the surface. But the neutrinos leave instantly, carrying with them the story of fusion. And in this thought experiment, you too dissolve into the fire. Your atoms are stripped, your nuclei caught in collisions, your mass transformed into energy. You are no longer separate, no longer body or self. You are light, heat, radiation. You are part of the furnace that powers the solar system. To fall into the core is to become the sun. And yet, even in this dissolution, there is peace. The core is violent in its collisions, but steady in its output. It is chaos, balanced into calm, destruction, balanced into creation. Every photon that will ever warm Earth begins here. Every neutrino that will ever pass through your body starts in this fire. You are part of that endless giving now, part of the light that touches everything. You are no longer a body, no longer matter as you once knew it. In the core, you have been undone, stripped into particles, folded into reactions. You have become energy. Your atoms, pressed beyond recognition, have joined the chain of fusion, releasing light and neutrinos that begin their journeys outward. To fall into the sun is to dissolve into radiance. The neutrinos are first to leave. They do not linger, do not scatter, do not stumble. Born in the instant of fusion, they rush outward at nearly the speed of light, ghostly and untouchable. They pass through plasma, through layers of the sun, through space, through Earth itself. Trillions of them cross your body every second without you noticing, slipping through atoms as if they were not there. They are the sun's messengers, direct and immediate, carrying whispers from the core across the cosmos. In this thought experiment, part of you is already gone, racing outward as neutrinos, leaving behind only silence. But most of you lingers, trapped as photons. Unlike neutrinos, photons cannot escape so easily. The radiative zone is a labyrinth, and each photon's path is twisted and delayed. A photon may travel only a fraction of a centimeter before being absorbed, re-emitted, scattered in a random direction. The outward journey becomes a random walk, billions upon billions of steps, lasting hundreds of thousands of years. To become light here is to become patience itself. Time loses meaning. Human years are nothing compared to the ages you spend wandering. You collide, scatter, shift, wander, inching outward at a pace slower than glaciers. Empires rise and fall. Species appear and vanish. Continents drift, and still you are traveling. Still you are scattering through the radiative maze. Falling into the sun does not end quickly. It is a transformation stretched across epoch, and yet you endure. Photons do not tire. They do not age in the human sense. They are reborn at every collision, re-emitted in slightly different energies, but still carrying the essence of the core. You become many photons, not one. You scatter into countless paths, countless identities, countless beams of light waiting to emerge. To fall into the sun is to surrender self-moved, to become multiplicity, to become countless instead of one. Eventually, after millennia, you reach the convective zone. Here, your journey accelerates. Plasma currents lift you upward, carrying you in great surging flows. You are no longer trapped in the slow crawl of scattering. You ride the tides of the star, rising with hot currents, sinking with cool ones, until at last you are carried to the photosphere. And then, suddenly, you are free. After eons of wandering, your escape is instant. The photon released from the photosphere races outward at the speed of light, crossing 93 million miles to Earth in just 8 minutes. After waiting longer than human history itself, you cross the solar system in less time than it takes to boil water. The contrast is startling, but beautiful. Patience gives way to freedom. Waiting gives way to motion. Where do you go? Perhaps you travel toward Earth, striking the surface of a leaf, joining the process of photosynthesis, fueling the growth of a tree. Perhaps you touch the ocean, warming its surface, stirring winds, driving weather. Perhaps you try human skin, felt as warmth, comforting, invisible. Perhaps you miss Earth entirely, traveling outward into the void, wandering between planets, perhaps beyond the solar system, perhaps for eternity. Every possibility is true, because you are no longer singular. You are photons scattered in every direction, neutrinos rushing outward, plasma feeding currents. You are part of everything now. To fall into the sun is not to vanish. It is to scatter, to spread, to shine. And as you imagine this, lying in the quiet of your room, you realize you are already part of this process. The sunlight that warms you, the food you eat, the oxygen you breathe, all are traces of the sun, carried across space, absorbed into life. Falling into the sun is not only a thought experiment, it is a reminder that you are already its child, already its creation, already its light. You have waited lifetimes inside the sun's labyrinth, scattering, colliding, wandering. Now, at last, you are free. Released from the photosphere, you stream outward at the speed of light, joining an endless flood of photons racing into space. After an eternity of patience, your journey has become effortless, a straight path across the void. In 8 minutes you cross the gulf between sun and earth. 93 million miles, a distance that once seemed unimaginable, passes in a blink. The space around you is quiet, nearly empty, offering no resistance. You are no longer trapped, no longer delayed. You are light, moving at the universe's ultimate speed, unstoppable, unless absorbed. Some of you race toward Earth where your path ends quickly. You strike the upper atmosphere, scattering into blue skies, painting the world with color. You strike oceans, warming currents that stir winds, driving storms that ripple across continents. You strike leaves where chlorophyll captures you, splitting water, building sugars, creating the energy that feeds every living thing. You are woven into food chains, into ecosystems, into breath and bone. To become light is to become light. Others of you strike human eyes, bringing vision. You paint the world in brightness and shadow, in sunrise and sunset, in the golden hues of evening and the silver glow of dawn. Without you, there would be no color, no sight, no perception of the world. You are not only warmth, you are meaning, the medium by which Earth sees itself. Some of you are captured by solar panels, turned into electricity that flows into cities, powering lights, computers, machines. Your energy, born in the fusion of hydrogen, becomes part of human civilization, driving its inventions, fueling its ambitions. Even here, in technology, you live on, and some of you never strike Earth at all. You travel past it, racing toward Mars, warming its thin atmosphere, touching its dust-red deserts. You scatter outward toward Jupiter, Saturn, Neptune, and beyond, lighting their clouds, painting their rings, glinting on their icy moon. You stream into the Kuiper Belt, brushing against comets, bending their tails outward. You travel into the farthest reaches of the solar system, carried on for billions of miles. And beyond even that, you may escape into interstellar space. Free from the sun, free from the solar system, you wander into the galaxy. Perhaps you will brush against a dust cloud, joining its glow. Perhaps you will travel between stars, unnoticed, unseen, until at last you fade into the faint background glow of starlight that fills the universe. Or perhaps, against all odds, you will strike a planet in another system, warming a world we have not yet seen, feeding life we have not yet imagined. There is no limit, no boundary, no wall to stop you. You may travel for billions of years, long after the sun itself has died. Light does not age, does not slow, does not decay. To become light is to become immortal in motion. Falling into the sun has made you eternal. But you are not one photon. You are many, scattered in all directions. Some reach Earth, some wander into the galaxy, some will never touch matter again. Each path is unique, each fate different, but all are part of the same radiance. To fall into the sun is to become multiplicity, to spread across space in infinite possibilities. And as you imagine this, you realize how connected you already are. The sunlight that strikes your face each morning is the very same journey, completed after hundreds of thousands of years within the sun, 8 minutes through space, and an instant into your skin. The warmth you feel is the story of photons that began in the core, born in fire, wandering through plasma, escaping into space, and finally touching you. You are not apart from them, you are part of them. The light that escapes the sun does more than shine. It shapes, it sculpts the earth, guiding every rhythm of life, every cycle of climate, every breath in the chain of being. To fall into the sun is not just to become photons and neutrinos, but to become part of the great dance between star and planet. On Earth, sunlight is time. It defines the difference between day and night, the turning of shadows, the rhythm of sleep and waking. The tilt of the planet gives sunlight angles, creating seasons. Summer is not closer to the sun, but angled toward it, the light more direct, the days longer. Winter leans away, the light slanted, the days shorter. The balance of these angles feeds migrations, hibernations, harvests, births. Entire ecosystems turn on the axis of light. Sunlight is weather. It warms oceans, lifting water into the sky, where it cools and falls again as rain. It drives winds that circle the globe, carrying storms, shaping clouds, stirring deserts into dunes. Hurricanes rise from its heat, spiraling over warm seas, carrying energy back into the air. Lightning cracks as air currents grind against one another, charged by heat born millions of years ago in the sun's core. Every drop of rain, every flash of lightning, every breath of wind begins with sunlight. Sunlight is growth. In leaves, in blades of grass, in tiny algae floating in the sea, photons are caught by chlorophyll and woven into sugars. Those sugars feed plants, which feed animals, which feed everything else. Every bite of food, every grain, every fruit, every drop of milk, every breath of oxygen is sunlight stored in matter, passed along the chain of life. When you eat light. When you breathe the result of light. To fall into the sun is to fall into the very act of living. Sunlight is even memory. Trees grow rings each year, marking the abundance or scarcity of light. Coral reefs record solar cycles in their skeletons. Ice cores trap bubbles of air that tell us how sunlight warmed Earth in ages past. The planet remembers light, holds it in stone, in ice, in growth. You are falling not only into a star, but into the record of its presence written everywhere on Earth. And sunlight is story. Ancient humans tracked its rising and setting, built monuments aligned to solstices and equinoxes, marked calendars by its path, festivals of fire, prayers at dawn, rituals of planting and harvest, all are woven into the sun's daily and yearly rhythms. Even now, the language of time, days, months, years, is written by the sun's motion across the sky. Falling into the sun is falling into history, into culture, into myth, as much as into physics. But this dance is fragile. The balance of light and shadow can tip. A small shift in sunlight over centuries can alter climates. Ice ages begin and end with subtle changes in the way Earth receives light. Volcanic eruptions or dust clouds can dim the sun for years, cooling crops, reshaping societies. Our lives depend on a balance so steady that we forget it can change. The sun gives, but it also reminds us of dependence. And yet, through all this, it remains constant enough for life to flourish. For 4 billion years, the Earth has circled the sun, warmed by its light, cooled by its nights, nurtured by its patience. For billions more, it will continue until the sun's story shifts into its next phase. To fall into the sun is to fall into that constancy, into the rhythm that has cradled life since its beginning. And tonight, as you rest, you carry that rhythm in yourself. Your own body follows cycles, sleep and waking, hunger and satiety, effort and rest. You are not separate from the dance. You are part of it. A small but essential note in the great song between earth and sun. To imagine falling into the sun is to imagine falling into that harmony, into the endless exchange of energy that makes life possible. The sun is steady, but it is not always calm. Beneath its constancy lies a restless heart, one that sometimes flares, storms, and lashes out across the solar system. To fall into the sun is also to fall into its tempers. The moments when its quiet glow becomes something wilder, something unpredictable, something that reminds us that stars are alive. Every 11 years, the sun cycles through solar maximum. During this phase, sunspots bloom across its surface, sometimes dozens at a time. Vast dark regions where magnetic fields twist so tightly that they block heat from rising. Around these spots, loops of plasma surge into space. Prominences flare, and eruptions become more frequent. The surface seems scarred, restless, alive with activity. It is during these times that the most dramatic outbursts occur. Solar flares, when magnetic fields snap and reconnect. Energy stored for days or weeks is released in minutes. X-rays and ultraviolet light pour outward, racing across space at the speed of light. On Earth, they disturb radio signals, disrupt satellites, interfere with navigation. To be near such a flare, falling through it, would be to enter an explosion that outshines stars. A burst of radiation brighter than entire galaxies for a fleeting moment. But even greater than flares are the coronal mass ejections, storms of plasma hurled into space. Billions of tons of charged particles erupt outward, traveling at millions of kilometers per hour. When they strike Earth, they rattle our magnetosphere, triggering geomagnetic storms. In the worst of these storms, power grids falter, satellites shut down, radio networks collapse. The Earth's shield holds, but it trembles under the force of the storm. The most famous of these tempests was the Carrington event of 1859. A massive solar storm struck Earth, setting telegraph wires aflame, shocking operators, painting auroras as far south as the Caribbean. If such an event occurred today, it could paralyze power grids worldwide, silence satellites, and plunge cities into darkness. The sun, gentle in daily life, has the power to shake civilization with a single breath. And yet, these storms are not only destructive, they are also beautiful. The charged particles that stream from the sun interact with Earth's magnetic field, funneling into the poles, colliding with atoms in the atmosphere. The result is the aurora, shimmering curtains of green and purple light that ripple across the night sky. To fall into the sun is also to fall into auroras, into the quiet beauty that arises from its storms. They remind us that even chaos can paint wonder. Sometimes, scientists imagine something even larger, superflares. Stars like the sun, under rare conditions, may unleash flares hundreds of times more powerful than anything we have recorded. If one occurred here, it could strip atmospheres, sterilize planets, and send civilizations reeling. Fortunately, such events are rare, perhaps once in tens of thousands of years. But the possibility lingers, a reminder that the sun is not tame. It is vast, powerful, unpredictable. For all its storms, though, the sun remains steady enough for life to flourish. Its tempers are brief compared to its long calm. It is not a destroyer, but a balance, giving energy, sometimes with a burst, sometimes with a storm, but always with generosity. To fall into the sun is to fall into both aspects, the calm and the chaos, the gentle warmth and the sudden flare. And so, as you drift tonight, think of those auroras rippling across Earth's poles, silent light born from storms 93 million miles away. Think of the sun's tempers as reminders of its vitality, its dynamism, its life. Even stars, even giants of fire, have moods, and in that truth, they are not so different from us. Imagine, for a moment, the sun gone, not fading slowly, as it will in billions of years, but vanishing suddenly, as if extinguished like a candle flame. It is only a thought experiment, but it reveals just how deeply life depends on this single star. For 8 minutes, nothing would seem amiss. The light that left the sun just before its disappearance would still be streaming toward Earth. The sky would shine. The oceans would glitter. The air would glow with warmth. But then, in an instant, everything would change. The light would end. The sky would go black. Stars would appear where once there was blue, and Earth would begin its descent into silence. Within days, temperatures would plummet. Oceans would begin to freeze at their surfaces, sealing themselves in layers of ice. Rivers would harden into white veins across the land. Winds would howl as the planet tried to balance warmth, but there would be no new heat to replace what was lost. Within months, Earth would be locked in an ice shell, its seas solid, its continents buried in frost. The atmosphere would thin as gases condensed, oxygen and nitrogen freezing, falling as snow. Without sunlight, photosynthesis would halt, plants would wither, food chains would collapse. The last warmth would come from geothermal heat, volcanoes, hot springs, fissures in the ocean floor. Around these, perhaps, small pockets of life might endure. But the vast world above would be still, frozen, quiet. And it would not only be light that vanished. Gravity, too, would be gone. The sun's pull, which holds Earth in orbit, would disappear. In that instant, Earth would fly off on a straight path, no longer circling but wandering. It would drift into interstellar night, a silent planet traveling endlessly through the galaxy. The moon would go with it, bound to Earth by gravity. Two companions cast adrift together. Without the sun, night would be absolute. Stars would shine, yes, but faintly, too far away to warm. The Milky Way would arch across the sky in brilliance, but it would give no heat, no comfort. Earth would be a frozen relic, drifting forever, its oceans locked, its air gone, its life extinguished. The silence would be total, the stillness infinite. It is a chilling thought, but it reminds us of something profound, how fragile our home truly is. Life thrives not because the universe is gentle, but because the sun has been steady. Its constancy is rare, precious, remarkable. To imagine its absence is to understand its value. To fall into the sun is not only to imagine destruction, but to realize the destruction that would come from its absence. And yet there is beauty, even in this vision. Earth drifting through the galaxy, a frozen jewel glowing faintly in starlight, its history locked in ice. Perhaps, after billions of years, it might be captured by another star, warmed again, awakened. Or perhaps it would drift forever, carrying its story through the night, a silent testament to the star it once circled. As you rest tonight, let this thought settle gently. The sun is here, burning steadily, giving warmth and light, holding Earth in orbit, cradling life. Its absence is only imagination, a shadow of what could be. Reality is brighter. Reality is the gift of light each dawn, the warmth of day, the constancy of a star that has burned for billions of years and will burn for billions more. The sun feels eternal to us, but it is not immortal. Like all stars, it has a life cycle, a story written in its fuel. To fall into the sun is not only to imagine its present self, and also its far future, a future billions of years from now, when it will change beyond recognition. For now, the sun is steady. It fuses hydrogen into helium in its core, balanced between gravity's inward pull and radiation's outward push. But hydrogen is not infinite. Slowly, atom by atom, it is consumed. In about 5 billion years, The core will run low, fusion will falter, gravity will press inward, and the balance will break. The sun's life will shift into a new chapter. As the core contracts under gravity, it heats further until helium begins to fuse into carbon and oxygen. The outer layers, no longer held as tightly, will expand outward. The sun will swell into a red giant, its radius growing hundreds of times larger than today. Mercury will be engulfed, vaporized in the expanding fire. Venus will follow. Earth's fate is uncertain. It may be swallowed entirely, or left a scorched, airless husk, its oceans long since boiled away. The sun's light will increase thousands of times over. What was once steady warmth will become unbearable heat. The skies of Earth will glow red as the horizon fills with the swollen face of the dying star. Mountains will melt. Atmospheres will strip away. Whatever life remains by then will be extinguished. To fall into the sun during this time would not be to fall into gentle fire, but into a swollen furnace blazing at its peak. This red giant phase will not last forever. The sun will become unstable, shedding its outer layers into space, forming a glowing planetary nebula. For tens of thousands of years, the nebula will shine, a halo of color, expanding outward, lit by the dying ember at its center. If you could watch from afar, it would be breathtaking. The sun painting its own epitaph across the night sky. At the heart of this nebula will remain the white dwarf, the sun's final form, no larger than Earth, but with a mass nearly equal to the star it once was. It will be a dense ember, glowing faintly with residual heat. No fusion will occur here. The sun's fire will be over. The white dwarf will shine with fading warmth, cooling slowly over trillions of years, until it becomes a black dwarf, dark and invisible, blending into the night. And yet, this end is not only loss. The elements created inside the sun, carbon, oxygen, nitrogen, will scatter into space, seeding new clouds of gas, feeding the birth of new stars, new planets, perhaps even new life. The sun will die, but its essence will endure. To fall into the sun is to fall into that cycle, into the knowledge that endings are beginnings, that death feeds creation, that stars live on in what they leave behind. If you look at your own body, you see this truth already. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were forged in stars long gone. Stars that lived and died if the sun was born. You are already the legacy of other suns, other fires. One day the sun will add to that legacy, scattering atoms that may one day form new worlds, new beings, new stories. So as you fall into the sun in this thought experiment, imagine not only its present furnace, but its distant destiny. Imagine the red giant swelling, the nebula glowing, the white dwarf cooling, the black dwarf fading. Imagine the cycle continuing, stars rising and falling, galaxies shifting, the universe renewing itself in endless rhythm. To fall into the sun is to fall into that rhythm, to see beyond one lifetime, one star, one world. The sun is more than physics, more than fusion, gravity, plasma, and storms. For as long as humans have looked upward, it has been story. To fall into the sun is not only to fall into fire, but into myth, into culture, into imagination. Across the world, civilizations have worshipped it. To the ancient Egyptians, it was Ra, the falcon-headed god who sailed the sky in a golden boat each day, and who slipped into the underworld each night to battle chaos before rising again at dawn. To the Inca, it was Inti, father of emperors, the source of life and authority. Temples were built in his honor, aligned so that his light would strike sacred stones at solstices. In India, the sun is Surya, radiant deity of light and truth, riding a chariot pulled by 7 horses. In Japan, the sun is Amaterasu, goddess of light whose retreat into a cave once plunged the world into darkness, until she was lured out again with mirrors and laughter. The sun has been God, guardian, parent, king, goddess. Its daily rising was resurrection, its setting, a passage into death, its return, proof of order, renewal, hope. Falling into the sun is falling into the heart of every dawn prayer, every festival of fire, every myth that told humanity we were not alone in the dark. It shaped not only religion, but also time. Stonehenge in Britain, the pyramids of Egypt, the temples of Mesoamerica, all aligned with the sun's rise or fall on solstices and equinoxes. The sun gave structure to calendars, agriculture, ritual. It was the clock before clocks, the calendar before calendars. Farmers sowed and reaped by its position. Priests marked holy days by its path. Entire civilizations were timed to its rhythm. Even now, the sun lingers in our language and culture. We speak of enlightenment, illumination, clarity, all metaphors of light. We call bright minds brilliant. We call moments of insight flashes. We equate darkness with ignorance and light with knowledge, echoing the oldest story of all, that the sun reveals, and without it we are blind. Artists have painted it, poets have praised it, musicians have sung of it. Vincent van Gogh's sunflowers tilt toward its glow. Homer's Odyssey warns sailors not to harm the cattle of Helios, the sun god. The Beatles sang, "Here comes the sun," and it felt like hope. Even in the modern world, with physics explaining its fusion and gravity, we still see in it more than a star. We see warmth, comfort, joy. We see ourselves reflected in its rise and fall. To fall into the sun is to fall into all of these meanings at once: science and myth, physics and poetry, religion and art. It is to recognize that humanity has always looked at this one star and found not only heat, but meaning. And even now, with satellites mapping its storms and probes diving into its corona, the mystery has not vanished. The sun is still more than equations. It is still symbol, still metaphor, still story. And tonight, as you drift toward sleep, you are falling into that story too. You carry the sun in your language, in your rituals, in your memories. You have watched it rise, watched it set, felt its absence in winter, its abundance in summer. It has shaped your life in ways you rarely stop to notice. Falling into the sun is a way of noticing, of remembering, of reconnecting to the star that has always been there, always above you, always giving. The fall is over. You have passed through the solar wind, the corona, the crimson chromosphere, the boiling photosphere. You have drifted in convective currents, wandered through the radiative labyrinth, dissolved into the core. You have been scattered as photons, fled as neutrinos, escaped into space, touched Earth, wandered into the galaxy. You have seen storms, cycles, futures, myth. And now, at the end, you understand. To fall into the sun is not to end, but to transform. For nothing is wasted. Every atom that enters the sun becomes part of its fire. Every photon born in its core eventually escapes, carrying energy across space. Every flare, every storm, every breath of solar wind is the sun giving itself away. And when its life ends, billions of years from now, even then, it will scatter its essence into the cosmos, feeding new stars, new planets, new possibilities. To fall into the sun is to join that endless cycle of giving. You are no longer separate. You are not a body plunging into fire. You are fire itself, light itself, warmth itself. You are scattered across Earth in sunlight on leaves, in warmth on skin, in the rhythm of seasons, in the auroras that shimmer at night. You are spread across space in photons that may travel forever, in neutrinos that pass through worlds, in energy that fuels galaxies. You are everywhere, because the sun is everywhere. And in this transformation, there is peace. The sun is vast, but it is not foreign. It is already within you. Every atom of calcium in your bones, every molecule of oxygen in your lungs, every heartbeat powered by food, all are sunlight stored in matter. Falling into the sun is not a journey away from yourself. It is a journey deeper into what you already are. As you close your eyes tonight, imagine not fire, not destruction, but warmth. Imagine yourself dissolving into light that touches forests, oceans, skies. Imagine yourself spread across the world in every sunrise, in every flicker of day. You are not lost. You are transformed. You are part of the cycle that connects stars and life, atoms and energy, matter and meaning. The sun does not ask for anything in return. It shines because it must, because fusion burns, because gravity and radiation hold in balance. And in that shining, it gives everything: warmth, food, time, meaning. You are falling into that gift now, surrendering to the rhythm of a star, letting it carry you, letting it soften you, letting it remind you that you are part of something vast and eternal. So rest, let go. The fall has already happened. You are already the sun. You are already its light, its warmth, its story. You are everywhere it touches, everywhere it shines. And in that truth, you are safe. You are infinite. 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 You are infinite.